Steam enters a turbine at a pressure of 20 bar and 360 degrees centigrade and expands to a pressure of 0.08 bar. It then enters a condenser where it is condensed to a saturated liquid water. So here the table gives the properties of water and steam at the saturated levels. This column gives the saturated enthalpy at 20 bar and 0.08 bar, and this column gives saturated enthalpy of steam at 20 bar and 0.08 bar, and this column gives saturated water entropy at 20 bar and 0.08 bar, and this column gives saturated vapor entropy at 20 bar and 0.08 bar. And here are the properties of superheated steam at 20 bar and 360 degree centigrade are as follows. Here enthalpy of superheated steam is 3159.3 kilojoule per kg, and entropy of the superheated steam is equal to 6.99 kilojoule per kg Kelvin. So it is a common data question. This is the data for two questions. The first question is drainage fraction of steam after expansion in the turbine is. Options are 0.5, 0.62, 0.83 and 1. Here 1 gives the saturated vapor line. Let us see. And coming to the second question, work done by the turbine is 562.6 kJ per kg, 678.5 kJ per kg, 971.6 kJ per kg and 1116 kJ per kg. Here first consider the steam power plant cycle on TS coordinates. Let us say the given steam power plant cycle is like this. Let's say this is the process 1 to 2 expansion in the turbine, and 2 to 3 heat rejection in the condenser, and 3 to 4 compression, and 4 to 1 gives heat addition in the boiler. So here from the table we can have some values like here the 3 represents the saturated liquid line and it is at 0.08 bar, and the upper line gives 20 bar. Here at 0.08 bar H3 or saturated enthalpy at 0.08 bar is equal to 174 kilojoule per kg, and S3 is equal to, that is entropy of saturated water line at 0.08 bar is equal to 0.593 kilojoule per kg Kelvin. And here on the line of 0.08 bar, the entropy of saturated steam is equal to 8.227 kilojoule per kg Kelvin. Now on the 0.08 bar line we can write SFG, that is the difference of SG and SF. So it gives a value of 8.227 minus 0.593 and is equal to 7.634 kilojoule per kg Kelvin. And now we can write S2, that is entropy at the exit of the turbine, that is S2 gives entropy at the exit of the turbine S2, but here the expansion in the turbine is isoentropy process, so here S1 is equal to S2, entropy at the inlet and entropy at the exit of the turbine is equal, so here S1 is equal to S2 and is equal to S3 plus X into SFG of 0.08. Here S1 is given by 6.99, that is superheated steam, entropy at superheated steam. Okay, and S3 is equal to 0.593 plus X into SFG is given by 7.634. So from this equation we can get here X, that is 6.99 minus 0.593 by 7.634, which is equal to 0.83. So here the dryness fraction of the steam after at the exit of the turbine is equal to 0.83. So this is the answer for first question, and in the option the correct option is C. C is the right answer for first question. And coming to the work done by the turbine, work done by the turbine gives H1 minus H2. H1 minus H2 gives work done by the turbine per kg of steam. Let us say here H1 is already known value, that is equal to 3159.3 kilojoule per kg. So this is the enthalpy of the superheated steam at 360 degrees centigrade and 20 bar. And here we will have to find out H2. H2 is given by H3 plus X into HFG, where H3 is equal to H4 because the compression is isoenthalpy process, the pumping process is isoenthalpy process. But anyway, here H3 is equal to the enthalpy on the saturated line at 0.08 bar, which gives 174 plus X is 0.83 into here Hg at 0.08, that is saturated enthalpy of steam at 0.08 bar is equal to 2576 minus Hf is 174. So here this value is equal to 2187.6 kilojoule per kg. And now the work done by the turbine is equal to H1 minus H2, that is 3159.3 minus 2187.6, which is equal to 971.6 kilojoule per kg. So here this is the answer for second question, and the right answer is from the options C. C is the right answer.